Hi folks, I'm Stephen Heumann, and today I will be presenting Adventures in 2GS Network Programming, AFPBridge, and beyond. So this is mainly going to be about a program I've written called AFPBridge, which allows you to connect to AFP file servers over TCP/IP. So I'll give an overview of that and a brief demo, and then I'll give some background on AppleTalk, because AFP originally, and in the original 2GS implementation, used the AppleTalk protocol stack, so you kind of have to understand that to understand how AFPBridge works. And then I'll get into some more technical implementation details of AFPBridge itself. And then in the final part of the talk, I'll kind of step back a little and talk about some ideas for other networking projects, which I don't have anything finished and implemented for that, but I do have some ideas, and I've written a little bit of code that I'll talk about. So first of all, I'll talk about AFP, which is the AppleTalk or Apple Filing Protocol. It was originally called AppleTalk, but Apple kind of renamed it when it was extended to work over TCP/IP as well as AppleTalk. And so it was a network file system protocol designed by Apple, which was originally designed in the 1980s, but has subsequently been updated. It's supported on pretty much all of Apple's platforms, although it's now considered deprecated. And in particular for us, the 2GS does have an implementation of it. There are also a number of third-party implementations. For example, NetAtalk on Linux is a widely used server for it these days. So AFP is a file sharing protocol. It's kind of similar to, for example, SMB. One difference with AFP is that it was designed by Apple, designed for the Apple system, so it supports things natively like resource forks and file types, which means it's convenient for working with 2GS files because it kind of natively supports these file system features that the 2GS expects. And another thing is that it runs, as I've mentioned, over the AppleTalk network protocol family, or now in more recent versions over TCP/IP. And so now to talk briefly about how AFP is implemented on the GS. It's implemented mainly in the Apple Share FST, although there are actually a number of other system components involved to some extent. And it works by calling into the Apple 2GS AppleTalk network stack. And it supports AFP version 2.0, which is the version from around the late 1980s when the Apple 2GS implementation was written. And it supports it over AppleTalk networks. And it uses the Apple Share control panel to locate servers. It'll give you a list that you can select from, and to mount an actual volume over AFP. You can also auto-mount volumes, and you can use easy mount aliases. So easy mount is a program that allows you to make an alias to a server, and then you can mount it later using that. But Apple Share control panel is essentially the core usual way to mount volumes. And once you've mounted a volume, it works similarly to a local disk. You can read and write files from it. It actually works under both GSOS and ProDOS 8, which is kind of interesting and requires some coordination between different components. So that's AFP on the 2GS. But there are some issues with actually using it in kind of a modern network environment in 2017. So one thing is that it requires you to be physically connected to a local talk network. So you use a local talk networking cabling coming out of the serial port on your GS and connecting to other systems. But these days, essentially, Ethernet is the standard for networks. So probably you want to use a local talk Ethernet bridge device. And there are a number of those out there, which are kind of older devices made in the 80s and 90s mostly. It's also possible to use an old Mac for that. But you kind of have to get a separate device to be able to do this in most modern cases. And since you're using local talk, you're also limited to the speed of local talk networks, and you can't take advantage of the Ethernet cards that are out there for the 2GS these days, which can deliver significantly faster speeds. You also require a server that supports AFP version 2.0 and supports that over AppleTalk networks, since that's all that the 2GS supports. And there were a number of options for this in the past, but pretty much the only modern one is NetAtalk version 2.x on Linux. And in fact, even that's not fully up to date because NetAtalk is now up to version 3.x, which no longer supports AFP 2.0 or AppleTalk networks. So you also are required to have a network that supports the AppleTalk protocols. So AppleTalk protocols, as I mentioned, can be used over local talk and with an appropriate adapter over wired Ethernet. In most cases, although Apple's AirPort devices can be an exception, they usually won't work over wireless networks, and they certainly won't work over the public internet. So that's another limitation for that. And you also have to have the AppleTalk stack installed, and you need to have your slots in the 2GS configured for it. In particular, you need to have on a ROM1, you need to have slot 7 devoted to AppleTalk, which is kind of inconvenient. So you have these limitations, and it would be nice to kind of address some of them. So AFPBridge does this, to a degree at least. And so it's a tool to allow connections to AFP servers over TCP/IP network protocols rather than AppleTalk. And it works together with the stock system 6.0.1 software together with Marionetti for the TCP/IP implementation. And AFPBridge itself is implemented as an init. There's also a control panel that works with it to connect. And it basically works by using the existing AppleShare FST and the AFP implementation in that, but intercepting its AFP requests that it tries to send out over the network and sending them out over TCP/IP instead. And so that's the core of it. There are a few options that are needed and kind of some adjustments that need to be made to improve compatibility. But for the most part, it's relying on the existing AppleShare FST for the AFP implementation. And so with this, AFP-mounted volumes will work as normal. They will work in all normal GSOS applications. They will not work in ProDOS 8 mode, which is primarily just because Marionetti doesn't work in ProDOS 8 mode. So now to speak to some of the benefits of AFPBridge, kind of compared to those limitations I discussed earlier. It works with any network interface Marionetti supports, in particular including Ethernet cards. That can allow you to have faster transfer speeds. There is an issue there with Marionetti versions because some versions of Marionetti include debug code that can slow things down. But with an appropriate version, you can actually get significantly faster speeds. And you can also use servers that support either AFP 2.0 or AFP 2.2, which is a slightly later version of the protocol, but it's pretty much compatible, and connect them over TCP/IP. And because it's TCP/IP, it works over pretty much all modern networks, including the public internet. One continuing limitation is that you still do have to have the AppleTalk stack installed and the slots configured for that, which is essentially because the AppleShare FST is designed on the assumption that those other system components will be available. So now I will give a brief demo of AFPBridge. So here's GS, emulated GS. And so, as I mentioned, there's a control panel. So you go to the control panels and you see this AFP mounted. You open that and you type in an IP address. Or rather a URL, which includes either an IP address or a domain name. And you hit connect. And you can open this share. So we have this A2 file staying open now. If we get information on it, we will see it is in fact an AppleShare file server. And if you look at where, it gives the server name as that IP address. And it gives the zone, which is a notion from AppleTalk networking, but in this case, we're kind of using a fake zone here called AFP over TCP. With this option, this LR is an option code for one of the options we've specified. And so you can do that. You can enter this URL, which includes the IP address or domain name, plus the name of the file shared amount on the server. There are also various options here, some of which I'll discuss a little bit. And so you can connect to that. You can also save an alias, which is actually creating one of those aliases for easy mount, that then you can connect to it later. And so we have a share here, and it works pretty much like you'd expect. You can open a file on it and see the file, and you could edit it. You could even open a program on it that's located on that share, for example, Teach. So you do that. That's kind of fun and interesting. You can see the arrows in the corner where it's indicating network activity, and so you can even open your program. So that's that. Now I'll proceed with the rest of the talk. So I first need to give some background on AppleTalk networking. So it was a network protocol stack that was designed by Apple in the 1980s. It, very broadly speaking, does the same kind of things as TCP/IP network stack and the protocols that run on it, but it's a whole separate protocol stack. And it does have some cool features like automatic configuration and service discovery. So it works over originally local talk networks, which is that networking using the serial ports. It can also work over Ethernet and other network physical networks, but as I said, not obviously over the public internet, not usually over wireless networks. And it's supported on various Apple platforms, classic Mac OS, old versions of Mac OS 10, although it was removed quite a few versions ago at this point, 2E with workstation code, 2GS, and also other platforms like Linux. It used to be supported on old versions of various platforms, including Windows, although a number of platforms have now removed it at this point. So it's mainly used for AFP file sharing and also printing, although it can be used for other things as well. So to now kind of show the various different protocols that make up the AppleTalk network stack, here's a diagram that shows most of them from some documentation from Apple. And so you can see at the lowest level, we have these link access protocols that correspond to the various physical network layers. In particular on the GS, since the only physical link that's supported is local talk, you're using the local talk link access protocol. And then above that is the datagram delivery protocol, which essentially just kind of sends one datagram, one message by itself from one system to another. So this is kind of comparable to IP. And then you have AppleTalk transaction protocol, which has this notion of a transaction where you can send a message and get a response and be sure that those were delivered and that they were, if you specify things appropriately, that it's processed exactly once, so it's a transaction. You also, above that then, have the AppleTalk session protocol, which that introduces the notion of a continuing session that can be opened and then can be remain open as potentially many messages are sent across it before it eventually closes. And then finally above that, you have the AppleTalk filing protocol, AFP, which is what we're directly concerned with. And there are also a number of other protocols involved here, most of which aren't really relevant to us. I'll just mention name binding protocol, which allows you to look up the name of a server or a system and get a network address for it, which is something that we will need to deal with later. So the 2GS has an implementation of most of these protocols. Some are in ROM, but it pretty much loads updated versions of all the protocols into RAM if you have the appropriate system software components installed. And so that, in addition to the protocol implementations themselves, there's a call dispatcher, which is responsible for kind of dispatching calls whenever you make an AppleTalk call to the actual appropriate protocol layer and the handler for that specific call. So that call dispatcher is actually used both when an application is calling into the stack, but actually more commonly when one component of that AppleTalk protocol stack is calling into a lower level component of it. And this stuff is all documented in a book called the AppleShare Programmer's Guide for the Apple II, which was available from AppDA. So if you want to work with this, you really need to get a copy of that book. And so now to kind of show the actual protocols that are implemented in the 2GS AppleTalk implementation, all these things with red circles are implemented by the 2GS. The ones that are dashed here are implemented but don't really have any calls to make to them because they're pretty simple protocols, at least from the client side, that you don't really need to make calls for directly. I put AFP as a different color. That is implemented, but it's kind of separate components, as I said, mainly the AppleShare FST, and then it calls down into the lower levels of the AppleTalk protocol stack. So now I'll discuss how you actually make AppleTalk calls and then how they're kind of dispatched. So the basic way you make them is that you have a parameter block, and you load the pointer to that into the X and Y registers, and then you JSL to this vector called RAM dispatch. And then RAM dispatch is responsible for looking at the parameter block, and there's a field in there that indicates what call you're actually making. It's a byte that indicates the command. And based on that, it will dispatch it to the appropriate handler for that specific command. And the way it does that is there's this command table in memory, which is actually in language code bank 2 and bank E1. That essentially just contains pointers to the various handlers for the different commands that you can execute. So it will look at that command table, index into it with the command byte, and then jump to the appropriate handler. So, and on entry to the command handler, the location of that parameter block will be in location $80. So these command handlers, the key thing here is that there's this table in a documented location. So the command handlers can be added and changed by modifying the command table. And that's what we'll actually be doing. So now to discuss a little bit about the 2GS AFP implementation specifically. As I've mentioned, it's implemented mainly by the AppleShare FST, but there are also a number of other components involved. In particular, there's an eTalk driver in GSOS that's responsible for kind of maintaining the GSOS notion of volumes when you're connected to volumes over AFP. There's also the AppleShare control panel, as I've mentioned, that mounts volumes. The interfaces for mounting volumes are actually documented, and the other tools can do that too. And in particular, EasyMount also does that, and it actually works independently of the AppleShare control panel. And this stuff also cooperates with the ProDOS filing interface layer. And ProDOS filing interface with PFI is the code that's responsible for allowing you to access AFP volumes in ProDOS 8 mode. But it actually is still involved even under GSOS too, as I'll discuss a bit later. So, kind of the key takeaway from this is that these GSOS components that are involved in the AFP implementation actually call down to the ASP layer of the 2GS AppleTalk stack. And so that's going to be kind of the key interface that we actually need to kind of patch into and intercept their calls at that point. So, and as I've mentioned, this supports AFP version 2.0 and only over AppleTalk and only as a client, not a server. So, to go into a little more about how AFP over AppleTalk works, it runs on top of, as I've shown, the AppleTalk session protocol, or ASP, which in turn is on top of ATP and DDP. But we primarily need to be concerned with the interface between AFP and ASP. So each ASP call sends a message to the other side, and in most cases it awaits a response. And most of these messages are actually client to server, although not all of them are. And also, most ASP messages are used to encapsulate an ASP message. So that's AFP. It has specific messages for opening and closing a session, getting information about the server, and for essentially sending commands and writing data. And also it has a thing called a tickle, which I'll get into a little bit more later. So now that was AFP over AppleTalk using the AppleTalk session protocol. And now, in around the mid-90s, Apple defined AFP over TCP/IP, which uses this thing called data stream interface. And data stream interface is a protocol that runs on top of TCP, but it basically corresponds directly to ASP. The protocol messages it sends are the same, with only one exception, which is that ASP had certain length limits stemming from the underlying AppleTalk protocols that are removed, which removes the need for one message. But apart from that, it's the same. And there's generally no difference in the encapsulated AFP messages, again, except for this issue with length limits. So that actually means that it's straightforward to translate from ASP calls that components like the AppleShare FST are making, and actually perform corresponding DSI operations to do AFP over TCP. And that's exactly what AFPBridge is going to do. So it essentially patches into that AppleTalk command table that I discussed earlier. It intercepts whenever you have a call to ASP, and it actually performs the corresponding DSI operation. And conceptually, it's really pretty straightforward. It does need to do some other things. It needs to track the state for the DSI sessions. So when you've connected to that, it needs to keep track of that. it needs to open and close the TCP connection when you start and end a DSI session using the ASP open and close connection calls, which get translated, of course, to DSI. And it also uses session numbers. So the ASP interface on the GS has this notion of a session number, which is a byte that specifies what session it is. So you can have multiple sessions going at once and distinguish them. And so we essentially use a distinct range of session numbers from the ones that ASP does. So you can distinguish ASP sessions from DSI sessions and actually potentially have both going at once. And for ASP sessions, if we detect that based on the session number, we just will pass it through to the original ASP layer to do the ASP call. So that's kind of the core of how AFPBridge works. There are a number of details that I haven't discussed, but that's the core of it. There is still kind of an issue of how you actually connect to a server. So here I'll show kind of the basic steps that a program to connect to a server has to make. So the Apple Share control panel does this with some additional stuff. EasyMount pretty much does this. It's possible for other programs to do it as well. So this is basically how you connect to a server. First you have to make a call, NBP, a name binding protocol call called lookup name, which takes a server name and a zone name, which is this notion in large AppleTalk networks. You can have multiple zones. So the server name, zone name, and the type of service, which will just be AFP server. And based on that, it can return an AppleTalk address, which is a network number, and node number, and socket number. And so you do that. I should mention NBP can also be used with wildcard lookups. So you can get like all the AFP servers in a zone using a wildcard, which is pretty interesting. And the Apple Share control panel actually does use that. Although that makes it more complex to support. So after you've done that NBP lookup name, you'll then call FI login2, which is actually a call in the ProDOS filing interface layer, which, as I've mentioned, is primarily concerned with working under ProDOS 8 to provide access to files over AFP, but it actually gets involved when you're making connections even under GSOS. So that takes your AppleTalk address and authentication information, and it internally calls something called SP open session, which is from the ASP layer that I've discussed, to actually connect to the server. And it sends the FP login message, which is an AFP message, to the server to actually log into it. And so then after that, depending on what kind of authentication you're doing, you may need additional steps to continue the login to do more authentication messages, which you use FI login cont for that. And then after that, you're connected. If you want to get a list of volume names, there's an AFP command for that you can send. And then once you know what volume you want to mount, you call FI mount vol to mount a shared volume. So that's the basic process for connecting to a server. It's possible to do a number of other more complex things, but that's the basic process. So now we want to support connections, of course, over TCP/IP. And to do that, if you'll notice, this process starts with a lookup name call. And you might, that kind of looks AppleTalk specific, but we want to adapt it to work over TCP/IP. So the way we do that is we intercept lookup name calls as well, which is, again, basically the same process of patching the command table. And then if it uses a special zone name, which is AFP over TCP, possibly followed by some option codes, then we treat the server name as an IP address or a domain name. If it's a domain name, we do a DNS lookup. And then we make a mapping from that from a certain AppleTalk address, which we'll specify, to an IP address. And specifically, we'll use kind of a fake AppleTalk address, which uses a special network number of FFFF, which isn't really a valid network number under AppleTalk. So we adapt that for our use of these kind of fake addresses that really correspond to TCP/IP. And then when SP open session or SP get info is called, we recognize those addresses and actually connect via DSI over TCP instead of actually using AppleTalk. So that's kind of our core process for supporting connections to a server. As I've mentioned, the code that actually does the connection will call into PFI calls and not call SP open session directly. But we actually wind up intercepting the call from PFI down to SP open session in the ASP layer. So that's basically how that works. But there are still some details that the Apple Share control panel uses that we aren't really supporting. So one thing it does is it will present you a list of zones that you can pick from. That uses something called Zone Information Protocol, which we aren't patching into. We could, but it would be more complex. It also uses wildcard NVP lookups to get a list of servers. So it'll show you the list of all the servers in the zone, and you can pick it from a list. That, again, is something we can't easily support. Under TCP, there's not really a direct equivalent to wildcard NVP lookups. Modern Mac OS X systems do achieve similar functionality using something called multicast DNS. We could potentially do that, but that would be considerably more work to support, so we don't. So the net effect of this is that we can't actually use the Apple Share control panel to connect to AFP servers over TCP/IP. And instead, we look to another program in the system software which actually also does that, and that's EasyMount. So what it basically does, it has these alias files which record the server name, the zone name, and the volume name to connect to. And it uses almost exactly that sequence of calls that I just showed to then connect to the server. And so we can actually work pretty well. We can intercept the calls from EasyMount, redirect them appropriately, and actually mount a server over TCP instead using that. And it's actually possible to invoke EasyMount in any desktop program. You just use a send request call and essentially ask it to open the alias file. So that actually is something we can work with, as we will see in the next slide. So specifically, we add this new control panel called AFPMounted, which allows you to specify a AFP server using a URL. So you need to specify, again, a domain name or IP address and the volume name to connect to. You can also specify a username and password. And based on that, it mounts the volume using AFP. So the basic process for that is first to place the URL, then construct a zone name that encodes the options specified. So as I've mentioned, we use these zone names that start with AFP over TCP, but can also include these various option codes after that that control how a few options work. And so we construct that zone name, and then we create a temporary EasyMount alias file that uses that constructed zone name. It uses the IP address or domain name for the server, and it uses whatever volume name you specified. And then just send a finder says before open message, which tells EasyMount to open this alias, and that will invoke EasyMount, and it does the actual process of mounting. So it works with that. You can also have an option to just save the alias file, and then you can just double click on it later to open it and drag it to your desktop if you want, which can be a convenient way to open things. So that's how it works. It actually does work with AFP over AppleTalk as well as AFP over TCP. Not that you necessarily want to use it for that, but the option exists using this AFP :AT/URL format. So using EasyMount was a fairly easy way to implement this. It leverages the existing code that's part of the system software, but it does come with a few limitations. And one of those is that only a kind of basic form of authentication called random exchange or guest access are supported. So random exchange is a form of authentication where you specify a username and password, and it uses some encryption, but relatively weak encryption that can probably be broken nowadays. So because of that, it's often disabled in servers, So you'll have to kind of go and enable that probably to be able to use AFPBridge with many modern servers. And another limitation is that you have to specify the volume name explicitly, just because EasyMount doesn't have any provision for kind of asking the server for that list of volumes and then presenting you with a list of them to pick from. So you just have to explicitly specify that. And it would be possible to not use EasyMount and kind of directly do all those calls I showed earlier. That would essentially just be more work to implement that and kind of implement all the niceties that EasyMount does. So that's the core of how AFPBridge works. There are several issues that kind of required some extra functionality and code in it, which I'm not going to go into in detail in the interest of time, but I'll talk about some of them briefly, and feel free to ask me more if you have questions. So one is AFP versions. As I've mentioned, the 2GS AFP implementation was designed to work with AFP version 2.0. Since then, there's been AFP version 2.1, 2.2, and various 3.x versions. So the 3.x versions are the native ones on Mac OS X, which include various new functionality such as support for long file names and Unicode characters, Unix-style permission information, things like that. So that's actually quite different and not supported on the GS, even with AFPBridge. But it is useful to support AFP 2.2 in particular, because that's the version, the first version that was widely used over TCP/IP on the Mac side. And there's no compelling reason you can't use AFP 2.0 over TCP. And in fact, a number of different servers do support that. But some servers, such as, for example, NetAtalk 3.x, require AFP version 2.2. So that's useful to have as an option. And AFPBridge does provide that. Essentially, it just kind of rewrites the login messages to force it to AFP version 2.2. Another issue is this matter of tickles. So a tickle is essentially just a message sent from one side of the connection to the other as a keep alive. And most AFP servers expect a tickle about every 30 seconds. And if the connection is idle, they will send a tickle and basically expect one in response. So there's an issue that it's kind of not straightforward to always do this because of some aspects of how things are implemented on the 2GS. So I've kind of worked around that. There is a workaround that involves essentially the AFPBridge reporting that it's going to sleep after every connection, which works on some servers but not others. So that's an issue that's somewhat still open, although I think we have pretty reasonable workarounds for it. Another issue is asynchronous operations. So as I mentioned, I think the AppleTalk stack supports asynchronous operations, where you essentially send a message to the server, then go do whatever else, and you'll eventually get a notification when the server gives a response. So that's supported in the AppleTalk stack. It does add some complexities, so it's not fully supported in AFPBridge at the moment, which isn't really a big problem because it's not very widely used, although there is at least one place where it's used that I have to kind of work around. Another issue, as I mentioned, ASP has certain limits on read and write sizes, which DSI doesn't have the same limits. So there's some issues around that, and that actually requires a few AFP messages to be kind of rewritten a little bit to account for it. And finally, there's the issue of performance. And so as I mentioned, it can be actually significantly faster than AFP over AppleTalk, but you do need to use certain versions of Marinetti, because I did some debugging work on this and actually figured out that this debugging code in Marinetti can slow things down significantly. So that's AFPBridge. And now in the remainder of the talk, I'll kind of jump out a layer and think about some other ideas that I think would be interesting to implement for networking projects on the 2GS. So kind of part of the impetus for AFPBridge is that the 2GS has this network stack built in for AppleTalk, which I think is actually pretty neat. but it's kind of an obsolete protocol family at this point. And so I think there are actually some interesting opportunities for kind of making AppleTalk interoperate with modern networks, or providing similar functionality in a way that works on modern networks. So one obvious one would just be to support the AppleTalk protocols over Ethernet. And this is, of course, what Apple's never released Ethernet card would have done. So at this point, we do actually have several Ethernet cards available for the 2GS, but they don't support AppleTalk. And conceptually, I think this is possible to do. At a high level, you would intercept some of the lower level AppleTalk calls and redirect them over Ethernet. I think it would be a probably more difficult project than AFPBridge for various reasons, but I think it's likely possible, and it would be pretty interesting to do. Another thing is to support block-based device access over the network. So AFP is essentially kind of a file-level network file system protocol, where you send commands to do things like read a file or write a file. You can also imagine a block-based protocol where essentially you're still using some other file system like ProDOS, but to actually read and write the blocks, instead of writing them on a physical local disk, you're sending them over the network. And I think that would be interesting to do. One thing it would allow is to kind of remotely access disk images on some kind of disk image server. So I think that could be something interesting to implement. And another thing is potentially to support other network file systems, such as SMB, for example, which I know there's been some interest in, by translating them to and from AFP. So what I mean by that is you can intercept the AFP operations the same way that AFPBridge does, but instead of just essentially retransmitting the same AFP calls over TCP/IP, you could actually translate them into some whole other protocol. Transmit those calls, get the results back, translate them back to what AFP expects, and then hand them back to the Apple share FST that way. And so that would be kind of an alternative way of implementing a network file system, as opposed to kind of the obvious way of just implementing an FST. I think it has some advantages and disadvantages compared to that, but it is potentially a viable option. So one advantage would be that you're essentially working with pretty much documented interfaces, which you're not for an FST. So those are some ideas for other projects that kind of relate to AppleTalk. Now I'll talk about another area that is not so related to AppleTalk, but is important for modern networking, and that's encryption. So essentially the modern trend on network communications today is to encrypt just about everything. There's been a strong move toward just encrypting the connections to all websites you access, encrypting connections to mail servers, just encrypting them everywhere. And this is generally a good thing. It provides a lot of security and privacy benefits. This is generally a good thing. It provides a lot of security and privacy benefits, but it's bad for use with retro computers because this is just a big piece of code you have to write and a bunch of extra computation you have to do. And in many cases, it may simply be infeasible for retro computers to do it. But I wanted to investigate if this can be implemented on a 2GS. And so TLS, which is the kind of the modern version of SSL, which is used for secure HTTP and various other protocols, has three main parts. And SSH, which is another protocol, the level I'm describing is also pretty similar. So it has authentication and key exchange, which is where the server and client kind of talk to each other initially, and the client verifies that the server is who it says it is, which uses public key cryptography. And in the case of TLS, it usually uses the public key certificate infrastructure with these kind of root servers that are a root of trust, and then you have a chain of certificates that you use to determine if the server is trusted. So that's authentication and key exchange. Then you also have bulk data encryption and message authentication. And these are the parts that are really used on every message that gets sent over a secure connection. So bulk data encryption is symmetric cryptography, so something where you encrypt a piece of data and then you can decrypt it with the same key, which is what you would have exchanged in key exchange. And then you also have message authentication, which is usually based on a cryptographic hash function, and that essentially allows you to verify that the message is what the server or the client originally sent and hasn't been modified. And I should mention, you can kind of vary these layers. In particular, encryption and authentication are sometimes combined, but that's kind of the basic architecture of it. So the question again is, can this be implemented on a 2GS? And so I've actually implemented some parts of it. So symmetric cryptography uses these encryption algorithms. There are various ones, but probably the most widely used modern one is AES. So I've written a 6.5.8.16 version of that is reasonably efficient. And I've also implemented several cryptographic hash functions that are widely used these days. And each of my implementations of these are pretty careful 65.8.16 assembly code, and they can process at least several thousand bytes per second on a stock GS, which is a lot faster than any other implementation I'm aware of. And I think it gets into the point where you could actually handle this encryption on a GS, realistically. But that doesn't address the public key cryptography part of it, which you use for the initially establishing a connection. And that relies on operations on big numbers. So numbers represented by hundreds or often thousands of bits, and doing some pretty complex mathematical operations on those. So that is pretty slow and pretty complex to implement. So I don't have an implementation of that, and I honestly can't say whether or not it's feasible on the GS. My intuition is that it may be in some simple cases, but not necessarily in general. So that's kind of where that stands. So my kind of conclusion for that part is that TLS and SSH may be possible to implement, but they are very challenging. And they may be more practical in certain setups. For example, you can use what's called a pre-shared key, where the server and client have kind of agreed in advance on a key or a password that they know about. And that can allow you to basically skip that public key cryptography step. So that may be practical in certain applications, although probably not for connecting to general servers on the internet. So that's a possibility. Also, if you had hardware to accelerate these cryptographic operations, obviously that would help. So that could be special purpose chips that are available to do that if somebody interfaced those with an Apple II. Another option would be to use general purpose processors. For example, something like a Raspberry Pi. If you have that connected to your Apple II, you could potentially develop a protocol to kind of hand off the cryptographic operations to it. I think that could be a valuable option too. So this would be a big project to implement. Even apart from the performance issues, there's just a lot of crypto algorithms and other aspects of the algorithm that you kind of all need to implement. And so I think that's potentially possible, but it's really kind of stretching what the GS can do. And it would certainly be interesting to implement it. Apart from that, I think there is still room to do exciting things in 2GS network programming. And I think one area of opportunity is to tie into the 2GS's AppleTalk network stack and kind of either modernize that or provide equivalent functionality in a way that works with modern networks. So I think those are some interesting areas of opportunity that I may explore in the future, and I would welcome it if some of you did too. So that's my talk. In conclusion, I'll just say I'll give the links for downloading AFPBridge, and also for downloading all my source code, including the code to AFPBridge, the code to those crypto algorithms I mentioned, and several other things. So all that stuff is basically available on GitHub. So that concludes my talk, and thank you, and I'll be happy to take questions.